everyone, it's Miss Mac here with another short video. This is our Polynomials Lesson 2, and it is part 1 of our lesson on multiplying polynomials. We have one learning objective for this video. Our learning objective is that we can multiply a monomial, so something with one term and a variable, by a polynomial, which is an expression that has more than one term, and there will be a variable in that expression as well. So before we get started, just want to recall something that we talked about in our previous lesson on polynomials. So a polynomial is an expression with two or more terms. And we said last time that the prefix poly just means many or more than one. There were also a few types of polynomials that we talked about. We talked about binomials and trinomials, and anything over a trinomial we just call a polynomial. And then, of course, a monomial is not a polynomial. It is something that has only one term. One last thing that will be really important for this lesson is our exponent rule that says when we multiply powers of the same base, we will add our exponents together. So that means if we had a squared times a to the fourth, that would give us a to the sixth power. Okay, so keep that in mind as we work on this lesson for today. All right, so there are two methods for multiplying polynomials that we're going to talk about in this video and that we'll use in future lessons on multiplying polynomials. The first is the box method, and we'll talk about how we do this, but it will basically involve having a box, and it'll look somewhat similar to the lattice method of multiplication that you may have learned in previous classes. The other method we're going to talk about is the distributive property, and this is one that we've used lots of times in Algebra 1 and that we will use again in order to multiply polynomials. So let's start first with the box method. Step 1 of the box method says that we will make a box with the same number of rows and columns as terms in our problem. So we made a box that is 1 by 2 because we have one term and we're multiplying it by two terms. After we've created our box, step 2 says that we will multiply each term on the side of the box by each term on the top of the box. So I'll start by taking my one term and write it on this side where I have one row. And then I'll take my two terms and write them along the top. I don't have to worry about the plus sign because both of the terms inside of my parentheses were positive. So what I'll do now is I'll multiply 3x by the two terms on the top of the box. So I'll multiply 3x by 2x squared, and then I'll multiply 3x by 6x. So 3 times 2, my coefficients, will be 6. So I multiply my coefficients first. Then I have x to the invisible first power times x to the second power. And when I'm multiplying powers of the same base, I add my exponents, so that becomes x to the third power. Next, I'll multiply 3x to the first power times 6x to the first power. So 3 times 6 is 18. And x to the first power times x to the first power is x to the second power, because when I'm multiplying powers of the same base, I add my exponents. The third step in my box method says to write your final product from the inside of your box with exponents ordered from least to greatest. So I'm going to take the two terms that are inside my box, and I'm going to write whichever term has the largest exponent first. So that's 6x to the third power. Inside of my parentheses, I was adding, and both of these are still positive, so I have an addition sign. And then I will write 18x x to the second power. And just to double check, I noticed that I'm writing my exponents from greatest to least. So I wrote my product in the correct order. Let's try multiplying one more time, but this time using the distributive property. So step 1 of the distributive property says that we will multiply the first term outside of the parentheses by the first term inside of the parentheses. So I'll rewrite my problem one more time. 4x times x to the third power plus 3x to the second power. And we have our monomial on the outside. We'll start by multiplying 4x times x to the third power. I know I have an invisible coefficient here of 1. So 4 times 1 is 4. And x to the first power times x to the third power is x to the fourth power. So our second step is now we'll take our term outside of the parentheses and multiply it by the second term inside of the parentheses. So now we'll do 4 times 3, which is 12, and x to the first times x to the second, which is x to the third. I have an addition sign inside of my parentheses, so I will bring that down. Our last step, just like we did with the box method, is to write our final product with our exponents ordered from greatest to least. And it turns out they're already from greatest to least, so we have 4x to the fourth power plus 12x to the third power. Our exponents are from greatest to least, so that is our final product. All right, everyone, I hope that was helpful. If you still have questions, go ahead and watch that video one more time. And if you're really struggling, send Miss Mac an email. If you liked this video, go ahead and hit the like button. And of course, if you haven't already subscribed to our YouTube channel, go ahead and hit the subscribe button now. Thanks for watching.